Good morning, Matrix. It's Michelle here again this morning, and this morning we are going to be looking at electrolytic cells. In particular, we're going to look at electrolysis. Right. If you can remember yesterday, I quickly went through some of the important points. Now, let's quickly go through some of the important points of electrolysis as well. You should have this page, and maybe on this page you'd like to make a few notes as I go along. And then remember yesterday I referred to this as our cheat sheet. Okay, so when we have any questions, we are going to go back to this paper to be able to get some answers from. Right, so let's just quickly first look at what is electrolysis. And this is quite important because you need to know this definition. Electrolysis is when electrical energy is converted to chemical energy. And that is quite important because very often they give you an electrolytic cell and a galvanic cell. And then they ask you which one is which. Now, how you identify that is that an electrolytic cell will always have an electrical source. If you have a look at the examples I have here, there are batteries. Right. So there will always be an electrical source. And what happens here is electrical energy is converted to chemical energy. Right. So that is the one thing we need to remember. The other definition that we need to know is we need to know that we have electrodes. And remember, those electrodes are going to be the rods that we are going to use to conduct the electricity. And then the other one is the electrolyte. Now, very often we are asked the definition of an electrolyte. Electrolyte is a solution that will conduct electricity. Right? And remember, it will either be a solution or it will be a molten ionic substances. And then, of course, we also need a source of electricity. Okay, so those are the things that we need in an electrolytic cell. And we've already mentioned to you that in an electrolytic cell, our conversion is electrical to chemical. Right. Okay, so this is basically all the theory you have to know. Then there's a little bit of background theory that you need to know. And I'm going to write that on the side of the page here. You need to know what oxidation is. Right, oxidation. And you need to know what, let's write reduction over here. You need to know what reduction is. And I'm sure all of you know that oxidation is the loss of electrons, while reduction is the gain of electrons. Have maybe forgotten this. I know most of the books use this learning tool. They make use of oil rig. Right. And remember, oil rig stands for oxidation is loss, reduction is gain. Okay. Then we might also have to know here about reducing agents and oxidizing agents. Okay, and remember, the agents are the ones that I always explain. They are the ones who go under cover. Maybe I'll just quickly do a reaction just to explain those to you for those of you who have forgotten. Remember, let's say, for example, you have got copper, and copper becomes copper 2 plus 2 electrons. That means copper has lost electrons. So this is my oxidation half reaction. And then what happens is we have chlorine, and chlorine gains an electron to become chlorine. Now remember what happened here? Chlorine gained, so this is my reduction half reaction. Okay, so remember now, my agents are going to be as follows. Copper is going to be my reducing agent. And why is copper going to be my reducing agent? Because if copper did not lose an electron or electrons, then chlorine would not have been reduced. Okay, that's how it works. And then, of course, we can also see that chlorine would be my oxidation agent or oxidizing agent. Because if copper did not gain an electron, if chlorine did not gain an electron, then copper would not have been able to give off the electrons, and copper would not have been oxidized. Right, so that is how we remember those. Okay, so that is basically the first thing we have to look at. Then I'm going to run through, just quickly, because I'm not going to teach you all of this again, I'm just going to run through the different electrolytic cells that we can get, and which ones they can possibly ask you and which ones are important. Remember, electrolysis, maybe I should just quickly go through that again. Why do we use electrolysis in industry? We use electrolysis in industry, number one, to refine metals, right? Number two, we can use it to break up chemicals. And then number three, we use it for electroplating. Now, these are the three main reasons we use them, and that's what we are going to look at. Personally, and I'm not saying you mustn't learn everything, but personally, I think this year we might get either number one or number two. We've had quite a few questions of electroplating. We haven't had one from 1 or 2 in quite a while. So you need to learn all of them, but that is my personal opinion. Right. And remember, I know nothing about what's happening in the papers, so don't take my word for it. Right. Let's quickly have a look at what examples we have. Right. The first example we have over here is the electrolysis of molten sodium chloride. In other words, basically, the sodium chloride has just been melted. Right? And what would happen in this case? Remember, when it is melted, we got sodium ions, and we also got chloride ions in our solution. And what happens now is the sodium ions gain electrons to become sodium, gaining electrons, so this is going to be reduction, right? While the chloride ions are actually going to lose electrons to become chlorine. So what would happen over here is on this electrode, we would get little bubbles, and those little bubbles would be chlorine gas. And this would be oxidation. Now, very important for you to remember, and this is something we can add here to our cheat sheet, is that reduction takes place at the cathode. At the cathode. And oxidation takes place at the anode. Now, I don't know if you have a learning tool to remember this. I have a learning tool to remember this. And my learning tool is that oxidation, there's a oxidation takes place at the anode. That is my learning tool, that how I remember this. So maybe you'd like to use that. Okay. Then you also need to remember that the negative side of the cell is going to be the cathode and the positive is the anode, because we are busy with electrolysis. Right. Now this one is quite an important one, the extraction of aluminium. Right. So I'm just quickly going to run through it once again. Here we make use of inert electrodes, and remember, inert electrodes are electrodes that are not taking part in the reaction. So what happens here is these electrodes are carbon. And what done with a cathode is they have made the cathode part of the container. Right. So you have a big area, surface area for your cathode. Okay. That is also made of carbon. And then my anode has been made of carbon rods. Okay. Aluminium is placed in there, or not aluminium, cryolite, which is, aluminium oxide is placed in there, which is Al2O3, right? And aluminium only boils or melts at a temperature of approximately 2000 degrees Celsius. So what they do over here is they add a catalyst. And this one's quite important, people. You must learn this one. They add a catalyst. And your catalyst is called cryolite. Right. And what does cryolite do? It lowers the energy, the boiling point. Right. And it comes down to approximately 1000 degrees Celsius. So it melts a lot easier. You must know the name of that catalyst, and you must know the function of that catalyst. Okay? So what happens over here is, once it has melted, we get aluminium ions, and we get oxide ions. The oxide ions are reduced. The oxide ions are oxidized because they gain electrons to become oxygen. And what happens over here is we get little oxygen bubbles. Okay. And the aluminium, on the other hand, gains electrons and it is oxidized and it forms aluminium. Right. The aluminium is quite heavy, so it sinks to the bottom over here. And then it is drained out. Okay? Where it is then cast in a certain way that they need the aluminium. What is quite important to remember in this cell, or in this electrolytic cell, is that this requires a lot of energy. And that is one of the disadvantages. Because remember, most of our energy is generated by means of burning coal, which means carbon dioxide is released into the atmosphere. And carbon dioxide is a greenhouse gas, and therefore that leads to global warming. Right. What also happens in this reaction is, once these oxygen molecules are released, they combine with a carbon in this carbon anode. So you actually get carbon plus oxygen to give you CO2. In other words, what is actually released into the atmosphere is CO2. And once again, this is a greenhouse gas, which leads to global warming. So this whole process is not very environmentally friendly. Right. And because the oxygen is reacting with the carbon over here, these carbon rods can get thinner and thinner. Right. So in other words, they get thinner, and they do need to be replaced from time to time. So that is quite an important one to remember. Right. The next one is with the refining of copper. Remember, we can also have the refining of other metals as well. They can make use of silver here too if they want to, but we are going to look today at the refining of copper. What does refining mean? Refining means to make it pure. So in other words, when the copper is mined, people, they don't mine it as copper. They get it as a big chunk of an oxide, which has other impurities in it as well. So what happens in this case is they make the impure one. The impure one goes to the anode. And the reason the impure one goes to the anode is because what we want to happen over here is we want the copper that is in here to be released in the form of an ion. Right. So what happens is we want the copper that is in here to actually gain electrons and become copper ions. Right. So that is what we actually want to happen over there. And then once we have the copper ions, because remember, this is now released copper ions into the solution. And once we have the copper ions, then those copper ions will gain electrons to become copper. Right. So on this side, we are going to get oxidation. The copper is going to lose electrons to become copper ions, where on the other side, those same copper ions are now going to gain electrons to become copper. So in actual fact, what is going to happen? This rod is going to get thinner and thinner, while the cathode is going to become fatter. Right. Because why? Copper is going to deposit on it. And eventually we will have one pure rod of copper. Okay. In this case, your electrolyte can be anything containing copper. In this case, they used copper chloride. Okay? They used copper chloride, and remember that the concentration of copper will remain constant. And why is that? Because as some of the copper as this copper is becoming oxidized, on this side the copper ions are becoming reduced. Okay. So that is the one. The next one is the electroplating. So remember, in this one, people, my impure metal is going to be on the anode. Okay. Now we get to electroplating. What is electroplating? Right, electroplating is when you have a cheap metal and you cover it with a more expensive metal. Right, a lot of that jewelry that you buy in town, it's gold today, and you pay R9.99 for a beautiful set of earrings, and it's gold today, and tomorrow it's no longer gold. Because what happened? They used a cheap metal, normally nickel, and they electroplated it. Right. So that is what electroplating is. And you need to know the process. Right. So let's have a look at electroplating. Remember, people, in electroplating, you want the piece of jewelry covered in the metal. And remember, electroplating is not only in jewelry. In the body, a lot of stuff also gets electroplated to prevent it from rusting. But now let's today pretend it's jewelry, because the girls, we like jewelry. Right, okay. So remember, I now want silver. And whatever I'm going to want to be silver, I'm going to place at the cathode. Now you wanted silver. So that means at the anode, you are then going to place that metal rod. So in this case, I want that object to become silver. So my anode must be a silver rod. My electrolyte must also contain silver, and it can then also, and then obviously it must be a salt. So in this case, they made use of silver nitrate. Right. So what happens in this reaction? At the anode, and remember, oxidation takes place at the anode. Right, and oxidation is loss of electrons. So at the anode, the silver is going to lose electrons. And then it's no longer silver. Then it becomes the silver ion. Then what is going to happen? That silver ion is going to gain electrons and become silver. And when it becomes silver, it's going to attach to your piece of jewelry on that way. And remember, what is going to happen? There's going to be a movement of electrons around the outside there. Right. So that is electroplating. And remember, we said that the one we want plated goes to the cathode. Right. Then the last one we are going to have a look at is the chlor-alkali industry. Now, this question is a dual question, because they can either ask you this in electrolysis, or they can ask you this under the chlor-alkali industry. Okay? Yeah, you need to know that there used to be other processes as well. There used to be a process called the mercury process, and there used to be a process called the diaphragm cell. Right. Now, those processes are no longer used anymore. Why not? Because they are not environmentally friendly. Okay. We just need to know that. Okay. They won't ask you those cells, but they could possibly ask you something like that. Let's quickly look at what happens at your chlor-alkali industry. The first thing I want to do is I want to draw in a membrane here. Right. Okay. Because in the chlor-alkali industry, the cell that we use these days is called a membrane cell. Right. And what happens with this membrane is it is what we refer to as selectively permeable. So it only allows certain ions to pass through. And the only ions it allows to pass through are the sodium ions and the hydroxide ions. The chloride ions remain on the left-hand side of the cell. Right. So what happens here once again? You are going to have brine, and remember brine is just a fancy word for salt water. See, right. So they are going to have concentrated salt water in here. There will be electricity, and then what happens is, remember at the anode, oxidation takes place. So the chloride ions that have formed are going to lose electrons and become chlorine. So once again, over here, we are going to get little bubbles forming. Those little bubbles forming are going to be chlorine gas. That chlorine gas is obviously relayed, and it is then used in the chlor-alkali industry. I'm not going to go into detail about the chlor-alkali industry, people, because I assume there's going to be someone else who is going to discuss that with you. But you need to know that is where they get the chlorine from. Right. On the other side of the cell, what happens? On the other side of the cell, we now have sodium ions. But remember, I also mentioned to you that you are going to have hydroxide ions. Because remember, you have water here. Right. And the water is going to gain the electrons from the chlorine reaction. And then it's going to form hydrogen gas and hydroxide. Now let's quickly see what happens to the hydrogen gas. Once again, we are going to get little bubbles here. And those little bubbles are going to be hydrogen gas. And that hydrogen gas, once again, is going to be relayed. Yes, I can see some of you already know where that's going to go. Aha. Eventually to the production of ammonia. But someone else is also going to discuss that with you, so I'm going to leave it at that. Right. So, what happens now is I also have hydroxide ions. Okay? And I have Na positive ions. So what happens? Those Na positive ions and those hydroxide ions then combine to give us sodium hydroxide. And that sodium hydroxide is removed from the bottom of the cell, and it is then used exclusively in the soap industry. Okay. So remember, people, this sheet is basically all that you have to learn. You must just understand this, and then most of your work is done already. Right, now let us see if with our cheat sheet and with the other things we know, if we can already answer some questions. Okay, I want to remind you, matrics, for those of you who didn't see me yesterday, I often write this stuff in shortened form because I do not want to